In this chapter, we're going to look at the scientific method. Sociologists have a commitment to the use of the scientific method in their research, although some are weaker than others, of course, in this area, just like in other professions. The basic steps in the scientific method are defining the problem, reviewing literature, formulating some hypothesis, selecting a research design, and collecting and analyzing data. Finally, a researcher develops a conclusion based on the findings of the research. The scientific method is a systematic, organized series of steps that ensures maximum objectivity and consistency in researching a problem. It is important to be able to distinguish between scientific and popular sources, as we are constantly bombarded with information and so-called facts. The scientific method encourages research to be a continuing, ongoing process. There's really no end to it because each new finding gives us new questions. And there's also always more than one way to look at any question or any set of facts and draw different conclusions. So as long as the important thing is to keep the conversation going so that we can have an idea of the best information that is available to us at a given time. As we get new techniques and measure things differently, and as more people put their brain power into a problem, we do come out with different understandings of how things work. Scientific method starts with an area of interest within which we then need to define the problem. Part of defining a problem is the development of what we call operational definitions. Often, we take for granted that we understand what is being said, when in fact the words don't mean what we think they do. If we don't ask and make sure, we may draw wrong conclusions. In your notes, jot down a time when you have been misunderstood, or when you have misunderstood someone else because you used a word differently. I bet you can come up with some pretty good examples of that yourself. An operational definition is an explanation of an abstract concept that allows a researcher to assess or measure that concept and to communicate about it clearly. For example, the word status could mean many different things. For example, sometimes it means how things currently are, as in, what's your status, or what's your current marital status? It can also mean prestige or respect, as in, that's a high status job. If you see a study in sociology about the relationship between status and unemployment, the operational definition that's being used for status would be very important. The study could be looking at a number of things, and it's important to know which ones the researcher intended. That sociologist interested in status might use membership in some exclusive social clubs as an operational definition of status. There are many other ways too, though, to define status that would give us different information and different outcomes, and from which we would draw different conclusions. What else could be an operational definition of status that could be used in this study? Write your answer in your notes. Reviewing the literature is a process that serves to refine the problem under study, to clarify data collection techniques, and to reduce avoidable mistakes. Peer-reviewed journals and published books and textbooks are a good place to start a literature review if you're doing research. Always follow the rules regarding source citation and to avoid problems related to plagiarism. A hypothesis is a speculative statement about the relationship between two or more variables. Variables are measurable traits or characteristics that are subject to change under certain conditions, or that can be different between two different people or in two different cases. The variable believed to cause or influence another variable is called the independent variable. The variable that is changed or dependent on the independent variable is called the dependent variable. Scientific studies often try to find cause and effect connections. Causal logic involves considering whether a relationship is cause and effect, with one variable leading to another. A correlation exists when a change in one variable coincides, but doesn't necessarily cause a change in the other. It might, but we can't be sure. A correlational relationship does not necessarily indicate a causal relationship. For example, roosters crow as the sun comes up each morning. There's most definitely a correlation between hearing roosters and sunrise. However, the connection is not cause and effect, right? Other factors are necessary to show cause and effect. Control variables are those factors that are held constant to test the strength of a relationship between independent and dependent variables. For example, if we were testing the relationship between race and attitude about law enforcement, we might want to control for things like income level or education or other factors of the respondents. That is, we might want to look only at people within the same age range or economic status or geographic region in order to simplify our analysis. Okay, so one more time. Correlation is only an indication that causality or cause and effect relationships may be present. Other factors are necessary to determine a causal connection. Please watch the video about the dangers of confusing correlation and causation and be prepared to discuss this in the discussion board. This is a tough concept, but one that's super important. Research designs guide researchers in collecting data. We'll talk more about research designs in the next section. A population refers to the group of people a researcher wants to be able to describe or to draw conclusions about. Most of the time, we need to select a sample to use in our research. A sample is a statistically representative selection from a larger population. Researchers collect samples whenever populations are too large to be studied individually. A random sample occurs when every member of an entire population has the same chance of being selected for a study. That rarely happens in real life. The tests or measurements that we use in analyzing data, need to be both valid and reliable. Validity refers to the degree to which a measure or scale accurately reflects the phenomenon under study or measures what it claims to measure. Reliability refers to the extent to which a measure produces consistent results with multiple uses. Research can either support or refute a hypothesis. Sometimes studies do refute a hypothesis, which then leads to reformulations about a conclusion and adjustments in research design. It is by no means a failure of the research. We've already mentioned control variables, but check back and make sure you know what that's talking about and why it matters.